In summation, that is why country music shouldn't really count as music and is garbage. All right, now that we're all agreed there, let's check the assignment. We had begun with 1 through 3. Now, these things, I have a sneaking suspicion. How many of your answers have plus n pi or plus 2n pi? Is every problem I gave you last night require it? We'll check. I think so. I don't know. We'll double check. All right. So we start with 1. The vocab stuff I'm always torn on. If you go through the book, they're very bold, and I don't think the vocab's hard to find. Do you guys agree with that? Like, are the vocab questions hard for you? Okay. If you put a synonym in place of one of these answers, am I going to let it slide? Like if it was a test, if like the first one says what? You have to something. Your goal is to something the function. Isolate's the right word, but if you were having trouble coming up with the word isolate and you said get it alone, like if you worded it differently, would I still give you credit? As long as the conceptual meaning's the same, I'm cool with it, just so you know. I do want to remind everybody, have you heard anybody going throughout the last couple days? So start listening, and you will. I would not reach into another bag of somebody else's stuff that they've been kind enough to share with a bunch of other people unless you want to spend your whole spring break sick. Throwing it out there. Okay. Gives me the heebie-jeebies. All right, number 2. We didn't talk about this word. General solutions? And if you have a different answer, I'm not going to just commit to saying it's wrong. Lay, when you're done with that crunchy bite, seemingly, will you tell me the word that you have? Somebody else has something other than general, I would guess. Extraneous is a good word. I'll tell you, the fact that we're writing these and saying, here are the solutions. If they said, here's a solution, and we crossed it out, then I would say it's extraneous. The general solution is the infinitely many. Like, and we'll see that language again. If I want a general solution, it's saying, hey, they all have this form. Because I don't really expect you to say 7 pi 6 and 19 pi 6 and 31 pi, like never list them all. Okay, and 3. That equation is a trigonometric equation that is of something type. Quadratic? Cool. If you did 4, there's your extraneous. Which I just want to stress again. What's the root word that you see when you look at extraneous? Extra is doing too much. Get rid of it. Okay. 1 through 3. Feel okay? Okay. 5, 12, and 16. Let's just check. Answers will vary. Wonderful. How do we check if it's an answer? If you do the tangent of pi thirds and you subtract root 3, do you get 0? On 5a, we're just checking, is it a solution? I think we just discovered an alternative way to do this because everybody looked at me like I was crazy. How did you do this? So there's 2 options. How many of you on your page, your first step, you wrote this and then you added root 3? Okay, and then you might have looked on the unit circle and said, what x gives me a tangent, or what angle gives me a tangent that's equal to root 3? That's a way to check it. That's valid. There's another way. If we had already gotten these answers and I wanted to see if they were right, instead of reworking the whole problem, how can I ever check an answer to an equation? Plug it in. If I plug in pi thirds for x, do you guys agree this would be the tangent of pi thirds minus root 3? And what is the tangent of pi thirds? Is it true that root 3 minus root 3 is 0? We have a solution. We're just plug and chug, check. 4 pi thirds. Does it work? Does it? Where's 4 pi thirds? Which quadrant? Everybody, I'm going to give you like 30 seconds. Point to, not 30 seconds, that's way too much. 5 seconds from now, I want you to point to 4 pi thirds. 5, 4, 3, 2, 1. I'm down with quadrant 3 people. Okay, check it out. I'm at 0 right now. Here I'm at 0. How many pi thirds have I gone to get to here? 3 pi thirds. It's just pi, you're right. If I go 1 more, I wind up down here. Sine is positive or negative down here? Negative. Cosine is also negative. So tangent should be what? Positive. I'm cool with this answer. It's going to be the same. We're going to get root 3 minus root 3 equals 0 when we check B. What if I'd given you 2 pi thirds? Would 2 pi thirds be a solution here? Why not? It'd be negative root 3 minus root 3 equals 0, which is nonsense and would not count. Cool. All right. On 7, we're just going to check yes or no, I think. Maybe. How about 7? Is this an answer? Scratch that. 12. Got me good. What are your solutions on 12? 2 pi thirds plus n pi. Okay, you guys are going to interrupt me. So check, because I have a sneaking suspicion that somebody in here has 2 pi thirds plus 2n pi, and you probably have 5 pi thirds plus 2n pi. Is that true? 2 pi thirds and 5 pi thirds? How many of you guys have those as your answers? Okay, are they plus 2n pi each of them? So let's look again at 12. We're doing cosine, right? Tangent? Never mind. I'm okay with that. Do we need to work through 12? Okay. Is there a harder version in 12 or 16? We'll just do number 12 real quick. Let's check out number 12. Tangent of x equals root 3. We can almost do this in our head, but we won't do it in our head. Tangent of x. This is number 12. I'm going to do one thing first. Instead of writing plus root 3 equals 0, can I just say equals negative root 3? I just subtracted root 3 from both sides right off the bat. Okay, how many of your guys' unit circles have tangents on them? Cool. Is there places where it's root 3? Okay, we just saw a couple of them, right? Pi thirds is positive root 3. What's 2 pi thirds? So 2 pi thirds is a solution then, right? X equals 2 pi thirds. Is there another place where it's negative root 3? 5 pi thirds. Okay, now for these, I've made a mistake because what did I include? Plus n pi. Now, if you have your answer and we make them right here, I'm going to say 2 pi thirds. First question, why would it be plus n pi? So I'm going to present this, and there's a bunch of answers, and I can see the logic going. I think that this is equally valid. Somebody could have this on their page. Why is it plus n pi instead of plus 2n pi?
It's a high rotation to get to either 5 pi thirds.
So I'm okay with that. But there's another bigger piece that's underlying that I don't know that I'm going to get you to walk to unless we really point it out. Why was it plus 2n pi with cosine or sine yesterday? And good. So I hear a lot of the language. It's a full circle to get back, and there's that going around. If we talk about the x's that are nice to plug in, what's the typical domain of cosine? Like, how big is the domain of cosine? Like, I know it goes forever and ever. What about one period? What's one period of sine or cosine? 2 pi. And that's the same question as when you guys say we go around. It's just, how far do we have to go? What about tangent? You guys are right that it does show up exactly half the circle around, but we can work these out without like seeing it's half the circle by just noticing that we're just going one full period of tangent further. That's all we're doing. Now, in the end, why can I only write one? So like if I don't have this one, I'm still correct. Good. They're both going to hit the same numbers, and we see it. If you have both, awesome. You're good to have both, but you can write it with just one. Okay. Deal. Questions on that one before we move on? Sold. All right. How about 16? What did you guys do? Can you say that with like 10 times the volume? Pi thirds plus n pi. We're looking at 16, right? Is that the only place it happens? Pi thirds plus n pi. Anywhere else? One more time. 2 pi thirds plus n pi. Now this one's different, right? You're thinking about cotangents right off the bat. Same thing. The plus n pi is entirely because the period is pi. Hit it.
I did pi thirds plus.
Sorry,
n
weird.
Pi, pi over 3 plus n pi.
So you're saying n pi over 2? So let's just think about that. Is 4 pi thirds an answer in this equation? Is 4 pi thirds an answer in this? Is it? Looks like it will be.
Yes.
I'm okay with that. Because we're hitting all the thirds, right? Yep, I'm okay with plus n pi over 2 if you'd rather. Sweet. Good call. All right. Up through 16, how are we feeling? Okay, we're going to try to blast through these really quickly. 17 through 23 are up here. If you need to check to see if we have different answers, if you feel comfortable with your math, I think I probably feel comfortable with it, but our forms might be different in how we write our answers. So I'm going to give you a moment to check those. Good. I'm okay with this one. We're going to look at this one today. Divided by 2. Square root. Root 2 over 2. Awesome. Yep, we're going to clear it. We are going to clear up 19 today. We're going to make 19 easier, so if that's where your question lives, don't stress. 19 and 21, we're going to see more examples of today. I gave them to you with the understanding that we've not done exactly those problems yet, but I want to see what you guys come up with. My guess is 19 and 21 are the two hardest. Maybe not. I can't get a read on you.
Oh, I thought
Okay.
it was the same thing.
You thought that, like, it was
Yeah,
just...
I thought it was
Okay, they are hard. So tonight, if you didn't do it, I'm going to add more problems. We do have to see that there's a difference between them. And just so we can put these together, what's the big difference between a problem like 17 and 19? Because they're very similar setup, but there is multiplication where? In the argument. This is going to tweak some stuff, and we're going to have to adjust for it. We could do it without looking at problems together, but we are going to go through this a bit more today. If you stopped because you were comfortable with the first couple, I would always caution, do these get easier as we go or harder as we go? If you're going to try to just do a couple, I would advise start at the end of it and work back rather than start at the beginning and do the first and second and say, oh yeah, I got these, because they do get harder. Cool. All right. 19 and 21, we are going to do more problems like those today. And let's see if I messed up the whole assignment. No, 23. How'd 23 go? If you haven't done it yet, we're just going to check it. N pi and 3 pi halves plus 2 n pi. I'm going to start being more mindful about per sections, where if I want you to skip them or not. If I don't say anything, I'm going to work with the assumption that you're allowed to, but if I specify, maybe there's a few that we should start, or I need to do a better job picking my problems. Okay, up through 23. Feels okay? 19, 21 are wonky. Okay, 25. Well, I don't know why I jumped to this page. Ooh, something different. Something very different has happened here. There's no more n pi's. Oh, hey, this time I'm not saying work forever and ever. They specify only values between 0 and 2 pi. So there's no n pi's needed. 25, we get 0 and pi halves and pi and 3 pi halves. On 27, you get 0, pi, pi 6, 5 pi 6, 7 pi 6, 11 pi 6. Cool. Awesome. We're going to keep kicking because, just a reminder, if somebody who asked for help to go through one of these problems didn't tell me the problem, if you wanted step-by-step solutions, one, come talk to me, right? I'll always help you with them. Or where else can you get them? Calc Chat, which is linked on your page. Like, yes, they are all there. Okay, up through 27, 29, pi thirds, 5 pi thirds, and pi. And last but not least, 36. How many of you guys tried 36? Okay. I'm psyched about that. Cool. How'd it go?
Good.
What'd you get? Pi thirds? Just pi thirds?
No, I got pi thirds, pi thirds, 1 pi thirds.
I think you have 2 extra.
I think
Pi thirds and
pi
pi
thirds and
thirds.
5 pi thirds.
Pi thirds and 5 pi thirds. My guess is plus or minus. That's where you're getting goofed
I
up.
think that's very.
Okay.
I don't know.
How did it go? Feeling okay with these? Feeling like you hate them? Yeah. It's okay to get stuck. Here's the deal. I don't think I'm going to take this right now. I'm going to add problems to it tonight. Cool. What? Did you already rip it out?
No, I didn't.
Well, what's your objection?
Nothing.
Are you sure?
Mm-hmm.
Why did you object?
No, I didn't object.
What was your noise for?
What?
Okay. All right. Let's do it to it. Yes. Okay. So for today, we are just continuing on. And let's see. Not that one. I'm all goofed up here. Not that one. Still not. No, it is that one. Yeah. Okay. Cool. Sweet. Let's jump right in. We are still in the same section. We have been doing some big uns. We have 2 specific types of problems that I want to work today. I'd love to just get you up on the board, but I don't know that I think you're going to do what I want you to do. But we're going to try. We're going to try to go to the board here in just a second. We're going to do a bit of it. My goal, and I'm going to try to stick to this, is I would like very much to have like a couple problems, 10 minutes up, and then we debrief, and then we can come back and summarize. Like, I want to go back and forth is what I'd really like to do. Okay, so let's check it. I'm not going to name this example yet. I want you guys to write this in your books, and I'm going to give us a problem here, and I want us to see if we can't come up with a way to try this. So here we go. My equation that the equation we're trying to solve, I want to know, when is it true that sine x plus 1 is equal to the cosine of x? And then I'm just going to put a semicolon here. And the book, they're not super formal with the notation, but I'm going to say x is in the interval from 0 to 2 pi. Your book will just say 0 to 2 pi. They won't specify x in the set of or in the interval. But just notationally, this is what it really is. We're just going to write 0 to 2 pi. Okay. There's a few ways that you can go through this problem. Now, anybody, if we're just looking at it, I'm going to give you guys, rather than just cold calling, give me like 45 seconds without physically doing the problem. Talk with your neighbors and see if you can come up with 1 or more approaches to solving this. Talk it out. We're just going to call out and see if we have any, what ideas come out, not if we have any. That's all.
We burned.
So what I'm going to start doing is there's an angle x that if I take the sine of that angle and add that to it, I get the same thing. Like that's the weird version. Somewhere on this circle, there's a or more than one. There's angles that if I look at the sine, it's right between the exact. Can you see where they are?
Then we
Sorry,
shortcut
take-
and we go to
Yeah,
some
if I take the sine and I add 1 to it, I get exactly the cosine. And if we look at some nice ones, like here, if I have the sine as 1 half, if I add 1 to it, this is
What? It's
so that point doesn't work. There are points on here that work, and our goal, like this one, coincidentally,
Sine and cosine minus 1. Oh my gosh, we don't have a tangent.
yeah. Now what I want is, rather than having to look at the circle and try to find them, because if it's here, we're never going to find it. We want a way to solve it. So if we were just doing algebra, what would you try? All right, I'm open to hearing some ideas. And notice, I didn't say good ideas or bad ideas. I just want some ideas. So I'll do each one of these in a different color, just so we can look. I think I know the most natural thought. What is your most natural thought? Subtract a cosine? Okay, so sine x plus 1 minus cosine x equals, that is a reasonable first thought. Anybody else have the same first thought? And you might have thought, well, I would subtract 1, or you might move stuff around. Anybody have a different first thought? Hit it. Co-function identities. Can you expand on that a little bit? So if and I'll try to, I don't know why I'm using red there. Can you tell me what you would like me to write down?
Change sine into cosine. I know. I see words right now.
Okay, so here is another valid option. We have used the co-function identities to say the sine of x is the same as the cosine of the complement. And that's nicer to say than what I have written. This happens to be true, and you can verify this. The sine of 30 is the same as a cosine of 60. Like, that's our co-function identities. Okay, any other thoughts? I could have changed cosine as well. Now, could I divide everything by sine if I wanted? I could get 1 plus cosecant plus cotangent, or minus cotangent, I'm sorry, equals 0. But then I still won't get them to match. Like every other problem that we've done, we've been able to make sines and cosines into the others, right? But to do those on every problem that we have done so far, we had to use which identity? When we were switching sines and cosines and using clever substitutions? Not so much the reciprocal. There's one more that when I see sine x plus 1, this is almost what I want it to be. I really want it to be the Pythagorean identity. Now, algebra is a fickle beast. And the cool thing about it is, maybe that's not true because algebra just says do whatever you want to do as long as it's allowed. Can I add something to both sides of an equation and still be okay? Can I divide both sides? Could I take the log of both sides if I wanted? Could I exponentiate both sides if I wanted? There's all sorts of stuff that I can do, and algebra just cares that you do the same thing to both sides, right? Okay. I want you guys in groups up on the board. That's all the guidance I'm going to give you. I just want to see what you come up with, and we'll play it short. But I'm going to get us some groups. I want you guys to come up to the board. These ideas here are good ideas, just so you know. But I want to see if there's maybe another one. I'm going to write one word up here, just without giving you, we've used this word. I am hopeful that somebody in your group or within this room can help us remember what this means. Not out loud right now. I think that maybe we could exponentiate both sides. And algebraically, this is allowed. Whatever I mean by this, I think it's allowed. But let's get some groups up here real quick. If you have no idea what I'm asking you to do. So, as we look at this, obviously if you're watching this on the road, you can't see it. But I just made a couple little comments in pink. I'm allowed to do whatever I want as long as I do it to both sides, with the exception of divide by 0. I can't do that. So this pink statement, whatever, I'm not going to go through all the little tiny pieces here unless somebody asks. If you're a freshman, you might do this wrong. My hope is that nobody here does it wrong. The other thing that I'm going to start doing is I'm going to start trying to put parentheses around my arguments every time. You guys do not have to. I'm okay if you don't. It's accepted if you don't. I should model the true way to do this. I will start doing that. My bad. Okay. Sine squared x plus, what does this FOIL out to be? 2 sine x plus 1 equals cosine squared x. Okay. Now, in pink, and again, everything in pink is just like my thought process that I'm trying to write down in a nice, concise manner. What's the whole point of using squared? So when we see this, I'm hoping that somewhere we get a sine squared x or a cos squared x or a 1, and we have a way to make this relationship happen. Okay. I'm stuck. What do you want to do? Let me rephrase. I have the option to change whatever I want, right? I can rearrange it, and I could put in something for 1. I could put this in for 1. There's a whole bunch of choices. One of these things is not like the others. One of these things is cosine. of x. Like I just said, I was going to do this every time, then I immediately stopped doing it every time. Cosine squared is fine, but it doesn't match all the rest of the stuff. Can we tweak this to somehow make it so that we can change a cosine to something with a sine in it? What is that something with a sine in it? 1 minus sine squared. I'm not going to write it, but by subtracting sine squared from each side, and I lied, I will write it. This cosine can be changed from this formula. I know that cosine squared, if I rearrange this formula, is just 1 minus sine squared. And I'm going to loop this back to here. Now, there's a few different ways we can do it. And in the end, it's going to be it won't impact the answer, whichever way we do it. We could, and let's see if I'm wrong. Nope, I'm just going to do this. Never mind. I'm not even going to worry about taking two different routes. Okay, so which means on my next line, I get what? Lay, I see you zoning out. Not like, I get it. It happens. Can you read me my next line?
Sine squared x plus 2 sine x plus 1 equals 1 minus sine squared x.
Are there questions? Nice job, by the way. Questions for anybody here? You have to be able to recognize that we're close to a Pythagorean identity and realize that we're allowed to do whatever we want to both sides. Okay, from this point, hard problem, easy problem. Okay, I'm going to do some big steps in one. So if you're doing this, I would leave room in case you need to. I'm going to add a sine squared to both sides, which would give me a 2 sine squared x plus 2 sine x. And what else am I going to do between these steps? I just added this to both sides, and I'll do it in pink. Plus sine squared. Anything else that I should? Let's subtract 1. Anything convenient happen? Hey, minus 1. Minus 1. Good. They're just gone, right? Cool, cool. Equals. Nope. It's different color and a different boldness, which I hate both of those things. Oh, no. Yeah, we're going to try it. What's still over here? 0. Okay, this looks gross, but it just looks gross. What can I factor out from both of them? A 2 comes out of each, and they both have a sine x. If I were to factor out a 2 sine x from these, and I'm going to use brackets just so that my parentheses don't blend so ugly, what stays inside? Love it. Sine of x plus 1. Still all equal to 0. Okay. We are working on the infinite number line, or are we only working from 0 to 2 pi? Okay. So I'm going to do a little bit of scratch work that maybe I should do more consistently, and I'll try. I know that one option is that either 2 sine of x equals 0, which if we wanted to solve this for x, how do you guys proceed? Divide by 2, and then I'm still looking for where sine of x is equal to 0. Do you guys agree with that? Where on the unit circle is x or sine of x equal to 0? 0 and pi. Now, it's natural for somebody to put this. I don't want you to put this last one. I'm going to make it obnoxious and like clearly there. Why don't we need to write this? It's not included. How do you know it's not included? The parenthesis she sees. Weird. Okay, deal. How about the other one? When is sine x equal to, what do we set this factor equal to? Sine of x equals negative 1. I just subtracted 1 from each side. When is sine negative 1? Okay. Now, there's something easy to overlook here that we need to be very, very mindful of. Is it possible that the x that we found, and it didn't happen to be here, but is it possible that we have a negative value? Like just in general, in an equation, if I have an x, x could be negative. If you square a negative number, what does it give you? A positive. If it were positive, and this is just an easy way to see that like something wonky could happen, and we squared it, what would it give it? What? If we square a positive number, what do we get? Odd. It's still positive. Is it maybe true that when we square stuff, we mess with signs without even thinking about it? Like whether it's positive or negative. Because squaring stuff is allowed, but something weird can happen. What's a